Okay, good afternoon, everyone. I hope you enjoy your lunch, and I hope the talk later will wake you up. And okay, so this is a section of interaction in the 3D space. I'm the session chair. I'm Kenning from City University of Hong Kong, and so today we have three papers and two notes. So the first paper will be from National University of Singapore SIGCHI lab. It's about Physical Loci, presented by Simon.
Hi everyone. Thank you, Ken, for introducing me. So I will try to keep it as interesting as can be, because I know you all had lunch and probably you want to sleep now. So let's start. So my name is Simon Perrault, and today I'm going to present you a project that's called Physical Loci that we did with my co-authors from NUS SIGCHI lab, but also from Telecom Paris. Sorry, I didn't want to forget them. So some of them are in the room today. But first, let me present you the context of that project. Actually, this is a home, and more specifically, current home tend to become smarter now. You have a lot of smart devices, such as you have aircon, or at least in Singapore we do. You have also music player, or central heaters, security devices, even light control, and other smart devices like interactive television. And while we talk about interactive television, actually moreover, this kind of device has a lot of commands as well. That's just a subset of many channels you can just watch on your interactive television. So when you are a user in that kind of home, you want to interact with all these smart devices, and actually, how can you input so many commands? Because this can add up to maybe dozens or even hundreds of commands. One of the solutions that we could use would be remote controllers. But either you may end up with one remote controller per device, or one huge universal remote controller that's not easy to use. Another solution would be to use a mobile device. I mean, all of us have a smartphone. We can add an additional app. But sometimes when you're home, your smartphone might not be with you. And also, the kind of apps for smart homes are usually very complex. You have to go through the hierarchy to find the correct device, and browse through long lists. So we would like to avoid that, actually. And we would like to offer a very simple way for users to interact with their smart homes. A solution we would like would be, for example, gestural interaction. Basically, for each command you want to invoke, you will perform a particular gesture that will be mapped to that. Now that I guess you probably actually wonder that is, if you want one gesture for each command of your system, it's still the same problem, actually. How can user remember so many gestures? Well, if we consider that each command is a concept that is mapped with a particular gesture, we can actually maybe make some use of memorization technique and train users to do so. For example, one particular method that is being used and is very well known is the method of Loci, or Loci, or Loci. I will go for Loci for today. Yeah, the name comes from, actually it's from Latin and not from Norse. It comes from Loci, that's a Latin word that means place or locations. That's a mnemonic device that's been used since antiquity by ancient Greeks and Romans. And it's used, you can remember extremely long lists with that. So instead of showing you a lot of text, I will just maybe show you a short video where we try to comment with you. Yeah, thanks, that website. Oh, method of Loci is also sometimes trained the memory palace, but it's the same thing, sorry. So this is a short introduction that may not make more sense. So the concept of Loci, in order to use this method, you need a familiar place that you know very well, and you need to picture that place in your mind. And within that place that you know, you will create a mental path, as if you were walking through that place on your own, like this. And for that path that you'll be remembering, there will be a lot of objects that you will see, actually. And for each of the objects you will see, you will associate one concept you want to remember. For example, if you want to remember your grocery store list, you will map to all the 5 objects shown here, like eggs, milk, butter, and this kind of stuff. Then, when you want to remember that list, you basically you do the mental work yourself through your mind. And because you know exactly each object on that path, you will be able to remember all the items. the method of Loci is actually extremely efficient. It is used to remember ordered list of cards and even thousands of digits of pi in memory context. On the other hand, because it relies on the creation of that mental path that you can see, it's costly, it's extremely costly. The main issue is that the first step of the technique is very costly. Another problem that we have is we use the method of Loci for remembering ordered list. And when it comes to commands, you don't want to order them, because if you want to access to the last command on your list, you're going to have to browse through your own mental path, and that can take sometimes even 20, 30 seconds. That's not very usable. So to overcome this limitation, we actually proposed Physical Loci. That's a new interaction technique that is inspired by the method of Loci. And also, in Physical Loci, the user do not need to create a mental path or a mental representation of a familiar place. Actually, user just simply needs to use the room that is around them, like this room, and locate objects, and basically create association between physical objects in the room and commands of a system. If we consider the following 5 commands, we can see YouTube, Weather Channel, Discovery Channel, CNN, and ESPN. We can create a simple mapping. So by the way, there will be a quiz at the end of the presentation, so I hope each of you can take like 20 seconds to try to remember the location of each of these. So I will start with YouTube, and I will put YouTube, I will think that YouTube can go on that upper light. There's no reason for that, absolutely no, for this one, no reason. The second one is the Weather Channel, because whenever I turn out my light on, it reminds me of the sun, and I like when it's sunny. So Weather Channel will go on that location. The Discovery Channel will go on the vase. The vase is full of flowers that kind of remind me of holiday and traveling, so Discovery Channel is a perfect match for it. CNN is because I like to watch news channels, maybe not CNN, but every morning when I take my coffee. And for ESPN, actually you may not see on that, but the frame here contains a picture of me when the last time I went skiing. That was a long time ago. So this reminds me of sport. I will maybe detail you how Physical Loci actually works and how people are able to remember the commands. So the first one, as I showed you, is it relies on a semantic association. We create a semantic link. This picture is me skiing, then it reminds me of ESPN. Same for the vase. The second part is, now we see the same place again, and I remove 2 other objects. But your object memory might be able to tell you that there was a frame of me. I keep on talking about that one anyway. And the second one is that vase of flowers. And now the spatial memory will tell you that actually the frame goes on the left side here, and the vase goes on the right side of the wall. So what's the strength of Physical Loci is the synergy between semantic association, object, and spatial memory to create a strong mapping that can be recalled easily and for a long time, as we will see. We implemented a proof of concept of Physical Loci in that room that was quite crowded with a lot of places. So if we see, in order to invoke a command, this user wants to invoke the clock command that's mapped on that object over here. And it basically just simply clicks at it this way, and maybe can perform a delimiting gesture such as closing his hand. And that basically invokes the command. For our experiments, we ran a user study, of course, on Physical Loci, and we chose 48 words. All of them are here. And our participant had to map them all with 48 objects in the room. That's an example of mapping that was actually created. And for recognition, we first used a Kinect, but we had some detection issues, so we just used a Wizard of Oz approach, because actually our main focus is on memorization and not pointing itself. So the first thing we wanted to investigate is how the user could create and learn mapping. And especially, we wanted also to know if they can recall for a long period of time. But also, I keep talking about smart homes. And in smart homes, most likely you're not going to be the only one living at home. So if I create a mapping on my home, it would be nice if anybody else can learn it and remember it easily. So we're also going to investigate that particular aspect. In the first experiment I'm going to present, we used 2 groups of users. The first group was active users, as we call them. these are users that create their own mapping with the 48 items. And the passive group are users that will learn the mapping that was created by somebody in the previous group, basically. So we had one active, one passive, one active, one passive, and so on. Also, to find out about the mid and long-term recall, the experiment was done in 4 sessions. In the first session, users would create or learn their mapping and practice a bit. Then they would come back the next day to check the short-term recognition. 1 week later, and also we were able to get partial data after 2 months. So if we focus on active versus passive, active are the one creating their mapping. Here, as you can see on that graph, this is the timeline. This is the number of expert selection, which means we were able to remember all of these items. And we can see that by the end of the first session already, we reached a nearly perfect recall. It's around 99%. For passive users, as you might guess, the task was harder because they had to learn a mapping that was not theirs. But what happens is actually the performance starts lower, but also reach the same level as active users by the end of the first session. Now, if we consider what's going on long term, or short term at least at first, we can see that even after 1 day, the recall rate remains the same. It's nearly perfect. After 1 week, it's around 47 out of 48. And more interestingly is, after 2 months, actually, on the partial data we have, we get around 90% success rate, which is around 44 items remembered by both groups. So overall, Physical Loci offers a good recall rate, even for long term. So this experiment also allowed us to understand a bit better how users would create the mapping. And there's quite a common strategy that's used by nearly every participant. The first thing is basically they would start with taking one particular association they prefer. So we had one of the users that told us that whenever they go back home, they remove their jeans. So they said, this is the door of the room. So it's as if I'm going back home. I remove my jeans and I put it on the door. Okay. And after creating one association, as you can see, it's a bit messy, but on the extreme right, you can see the jeans is on the door. And people will create a spatial cluster, spatially consistent cluster. As we can see here, all the items from the clothing category are within that red circle. That's a big cluster. And also, we also found out that some strategies that were used by 2 particular users didn't work so well. So if we consider the blue locker that you can see on the left here, we can see that it's a locker with 8 doors, 8 blue doors, and all of them are the same. And also, all of that is mapped with animal names. Actually, this doesn't work very well because there's no way to really distinguish the Locis. So people will always mix the animal location. And another participant used alphabetical ordering. But this strategy doesn't work because it also, you need to remember all the items within a cluster as well as the alphabetical order. It's too much information to remember. Now, as you saw a bit slightly earlier, there's a bunch of objects, and you can see that some objects are mapped on a chair. So you may be wondering what will happen when these objects will move, because when you're in the living room, you move things over. So to understand that, we ran a second experiment. We decided to lower the number of items on 25 items. And this time, we chose 25 clusters of 5 objects in the room, and we forced the user to create the mapping between the 25 items and the 25 loci. And we were configured between the 2 sessions. We changed the spatial configuration of the clusters. For the first cluster, here on the left, we just operated a translation. We took all the items in the same order and put them on the other side of the room. For the second one, we shuffled the items within the cluster. So the cluster remains at the same position, but the items within it, the order is changed. The third one is used as a baseline to compare with the performance of the 4 others. The fourth one, we removed the cluster and we scattered all the items in the room. And the fifth one, was translated from one point to the other one and shuffled within the cluster as well. If we compare the recall times, we can see that users were actually overall faster remembering the items that didn't move, of course. That's because for objects that did move, they would need to perform a visual search that would take them some time. However, the recall rate there's no significant differences in terms of recall rate, which means that basically that bothers the users a bit, but they still remember the associations. So as a conclusion, we presented Physical Loci, an interaction technique for smart homes to recall and invoke commands. Physical Loci relies on the strong synergy between semantic association, spatial memory, and object memory. As we saw, Physical Loci allows for long-term recall rate and is also a unique shareable memory device because the mapping can be shared between users. And now, the moment you're all waiting for, I guess, is the final quiz. So, if I'm going to ask you, does anyone remember where the CNN was located? Please? The coffee? Damn, you're good, guys. Okay, how about the Discovery Channel? You're cheating, sorry. And how about ESPN? Yeah, the amazing picture of me. And the Weather Channel? Okay, and the YouTube? And why did I put the YouTube on that one? Exactly. Thank you very much. If you have any questions. Oh, sorry. Of course, it was the reconfiguration was done by the experimenters and not the participants, of course. Yeah. No, the visual search time, there's no significant differences between all the four but baseline conditions, basically.
Are you familiar with Simon Biggs, University of South Australia? Are you familiar with the idea of memory theatre?
Sorry?
Memory theatre.
Memory theatre? Yeah, I guess it's nearly the same. It's method of Loci, it's nearly the same concept.
Yeah, it's very similar. Ancient Greek technique the rhetoricians used to remember what they had to say, and they encode their speech onto objects because they weren't allowed to read it out.
Yeah.
And of course actors use that technique today.
That's another name for method of Loci, actually. We use the Latin name for it.
Yeah, okay.
Hello, I'm from Tsinghua University. I'm UConn, and I have two questions. The first one is that do you have something to ensure your to quantify if it is the best map that people do? The best mapping that people map the objects to the thing you, and the other is that if we often switch the occasions, the same object that does mean the same thing you want to remember.
Okay, so the first thing is the mapping phase was actually timed, so it's between we put between 15 and 20 minutes maximum, and it's around 70 minutes on average. And for the second question, if I'm correct, what happens is when you change the location of an item, is the visual search will happen for the first few occurrences of the time you're looking for it, but you will update your mental model for it. So if you switch it back, you will have the same problem again, but you most likely will be able to update the location of the item. Yeah, takes some time, but it should be fine.
Hello, I'm Mauro from University of Stuttgart. I have a question. During your study, did you find any average trend for item assignation, or it's completely customized for each subject separately?
Sorry.
So the people tend to assign, I don't know, coffee for news in several cases, or it's completely separate the results?
So actually we try to choose stimuli or items that where obvious association couldn't be done. For example, we didn't choose color names because that would have been very obvious. There might have occurrences of two users maybe locating some items at the same location, but there's no general trend of. That's something we wanted to avoid, is everybody doing the same mapping. That didn't really happen. There's no such trend.
Thank you.